So you're gonna have the equations. I think the equation is like this: R1 minus R2 times the correction factor is equal to 0. So you bring this to that side. So R1 is equal to R2 times x. So for the correction factors, you're gonna have R1 over R2. So for R1 over R2.
You gotta come clean this room up, guys.
Okay.
Alright.
2 minutes and we'll stop.
Okay, leave the door, leave it open, because she gotta
Yeah,
come
okay.
clean it. It's the only room she didn't clean on this floor, okay?
No problem.
She just told me.
For R1, R2. R1 we get 20 over 6, and for R2 we have 19.77. So your correction factor is going to be 1.04. So for this one, correction factor is 1.04, and it's for all of this. So the last step. For this columns, you're going to take the correction factor times this. Like what we had before, like the formula. You're going to take this times your the second table, the volume from the second table. This is times, and then take that plus this. This times this plus this. And the number is going to be in your final column. So you're going to have 52.9, negative 52.9, 186.05, negative 199.0402, 12.98, 50.87, negative 50.87, and negative 178.4. So now we have all the moment for BA and everything. So now draw the moment diagram. That's it, where you have 1, 2, you have A, B, C, D, E. B, C, D, E, F. Okay. So for BA, positive 52.9. Positive is counterclockwise, so you could put counterclockwise.
Clockwise.
52, yeah, clockwise, I'm sorry. And for this one, it's counterclockwise. BC is counterclockwise. Okay. C, D, wait. Damn. A, B, C, D, E, F, A, yeah, sorry, like this. And for BC is negative, so it's counterclockwise. Counterclockwise is going this way, so it's like this. 52.9. CB, C to B, positive, so clockwise. 186.05. CF, negative, so it's counterclockwise. 199.12. CD, positive, so clockwise. And for DC, CD, DC, D to C, 50.87, positive, so also clockwise. DE, negative, counterclockwise. FC counterclockwise. So now let's draw the Moon diagram. So this is my positive side, negative side, positive, negative, positive, negative. Wait, inside is positive, 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 negative. So for this one, I put the trapezoid side convention. In this case, A is a pin, so no movement, so you start from 0. And for this one, this side, if you look at this side, this is positive. If you look at from this side, this is positive. So this is going to the opposite of this, so this is negative. So you're going to have, since you didn't have any pointer, so you're going to have negative up to 52.9, because this is negative. Right? Yes. And for this one, B to C, you have, so you had, all messed up. From this side, this is going this way is positive, and this one is going opposite, which is this way, so this is negative. Negative 52.9, so negative 52.9 should be from here. And you know when you have distributed load, and for this one, let me see, let's count this one. For CB, CB is turning that way. So this way is positive, this way is negative. So you're going to end at negative 186.05. Because from the right side, turning this way is positive, and this one is turning that way. So if you're turning that way, it's going to be that, so it's negative. So this number is coming to the negative. And you have distributed load, so your moment is going to look like this. And for this one, I'm going to put my side convention like this. This way is positive, positive. For this one, turning this way is positive, and this is turning opposite. So this is negative. So you have to go to the negative side. 178.4 at this point. Wait. This is FC. FC is counterclockwise. Turning this way. Yeah. Turning this way. So if this is negative side, FC, turning this way. Oh shit. FC and is counterclockwise. So counterclockwise is like this. So it's positive. I messed up with this because it's counterclockwise. So from this side, which is this side, so it's same direction, so it's going to be positive. 178.4. And you didn't have any pointer in between, so you need to look at FC, so you have to look at the CF. CF is this way, 199.02. This way is, according to this is positive, and this turning this way, so it's negative, so you have to end at negative. Negative 199.2, so this, and at that point. Damn, it's all messed up. Yeah, but if you follow, you should know how to do it. For CD, you're going to put your side convention. This is positive, this is positive. So from the left side, turning this way is positive, and your CD is 12.98, and also pointing this way, so it's positive. So you're gonna have go up at this point, and for this side, turning this way is positive, but this is going that way, so it's opposite, which is negative 50.87. So you have to bring this. This one you didn't have any loading, right? Yeah, no loading. Nothing. So you're gonna have linear. Keep that one over there. No, send it wrong way. This one is for DC. DC. Okay, yeah. And it's at 50.87. You know, when you have moment at this point, you have to bring the negative side because this is negative. It didn't end at 0, so you have to carry this to the negative side of this thing, and which is equal to negative 50.87. So for the last part, D to E, you have this. Let me draw my side convention. This one is turning this way, which is 50.87, going this way. So you're gonna have negative. That's why you have negative right here. So this, you have a pin here. So you know your moment is gonna end at your pin, which is 0. So yeah, that is your moment diagram. So you're gonna have something like this. Just let you see it clearly. I'm sorry guys, but I have no choice.
So okay.
You're gonna have, bring this, not too much. Same thing. I'm gonna have, not the same point, you should, and this one's too much. Something like that. Parabolic, linear, linear. And this one you're gonna have this. And you know, if this didn't end at this 0 point, you have to put this because this is negative. So you have to bring it to this side. And you know, you have a moment here and you have a pin here. You didn't have any point low or distributed low this side, so you can just bring it to 0. But for example, if you have a point load acting this way, you know point load is going to change the shape of this moment, so you're going to have something like this. But in our case, we didn't have any point load at the span, so we don't have to do that. All we have to do is just bring